All right, in this lesson here, what we're going to be doing is talking about structures. Now it's time to take variables to the next level. Make them cool, if you will.
Snazzy.
So throughout this lesson, what we're going to be doing, we'll talk, of course, about what a structure is. And then we'll take a look at the syntax, how to set one up. Of course, some examples. Examples are great.
Examples are cool.
Dan's taken the time to come up with some really groovy Dan Bissell patent tutorials.
I like them.
Denissal examples.
Joel
They're
helped
cool
a lot,
examples.
too.
Yeah.
Yeah.
He helped by nagging, right? Dan,
Yeah,
are you
he
done
did.
yet? Dan, are you done yet?
Yeah.
Dan, are you done yet?
I do good at that.
Okay, so of course we'll take a look at declaration, using structures. We'll talk about dot notation, arrow notation, and even structures with pointer data. So a lot of cool stuff here.
Oh, yeah.
Joel, take it away.
All right, so the first thing is, what is a structure? Dan, what is a structure?
A structure is a grouping of variables that form a unified concept
All right.
that we can use throughout our code as a variable.
Okay, so like a real-world example. Real-world.
Real-world example. Let's say we have a point out in space.
All right. Sounds familiar.
Does it sound familiar?
Yeah.
Well, in 3D we have X, Y, and Z.
Right.
Right. We can make that into a concept in C++
Right.
by making a structure out of it. So we can define a structure with 3 variables: float X, float Y, float Z.
Right.
This is in comparison to, say, in our program that, like we've been doing, we'd have to define float X, float Y, float
Right.
Z.
So
and
that
it's
is-
not one unit.
Yeah, these 3 different variables that
Yep.
you're keeping up with.
So now we're
But
compacting
now
it
you
into
can put
one
this
specific
into one thing
That's right.
called
Point.
point or...
I don't know.
Cartesian coordinate.
Ooh, yeah.
Yeah.
That's nice and fancy. Lots of
Ooh.
typing.
Those are school words, man.
Yeah, I know, school words. LP,
And then
I'm with you.
And then you can make an instance of that. Basically, you're just creating a variable.
That's right. And it's
then-
all contained in that one central
That's right.
unit.
So now you can just refer to it as whatever variable name, dot .x,
Right.
dot .y, and
But that's
it.
dot notation.
And we're
Yeah,
getting
we'll
to
get
that.
into
So,
that.
so here I am jumping the gun. Oh, wait a minute. Let me student mode. Hi, Joel. We're talking about structures. Let's go.
All right, first thing. Let's go into here and create a structure. So,
Yes. So how do we define a structure?
just start it with struct and followed by the name of your structure. So in this case, let's create a character struct.
So that name right there would be equivalent to, say, int or float.
Like
or
type in struct int. I mean, if
You can't do
Yeah,
that.
I know you can't do that, but I mean, for the beginner out there,
Right,
like
sort of,
you're-
kind of, yeah.
This is where you're defining
The name of it.
data type that you can create variables from.
Yes.
Right.
Yep.
So what does our struct want to have? Well, inside of it, you can put anything. Height,
characters,
weight,
yeah.
age, gender, name, all sorts
Stay
of
away
stuff.
from the age.
Yeah, but that's only for, like,
Yeah, so
you.
don't make a buzz character.
I'll remember not to do that.
Okay, good.
It might overload the integer.
Oh, you're so dead.
Yeah. All right, so first, not caps. Int age. And we can define any data types we want. So inside of here, another one. Car, char, gender, which just holds M or F.
That's right.
And finally, well, actually, we'll get to that in a second.
Or Z for Zach.
Yeah.
He's special.
He is special.
That's right.
Yeah. So we have to end this off, the structure, with a semicolon. Now we can use inside of main this data type that we've created. So we can define it just like we do like with int. Instead of int, we can say character.
And then we give it a name,
Zach.
which is going to be our variable name.
Right. So we can say character Zach.
Okay.
And inside of Zach, we can say, Zach dot age equals, I don't know how old he is. maybe
22.
22.
45, sweet.
Let's say 22. And for gender, we can just say Zach.gender equals
Oh.
Z.
Z for Zach.
Z for
Because
Zach.
he is his own special person.
Yes, he is.
But
Zach is unique.
just to get back to some
Special.
technical words again, this is called dot notation.
Yeah, that's right.
And the interesting part, which you can see if Joel decides to type dot again,
Oh, yes.
Zach dot,
Zach, which is the data, the variable that we've defined. And if we say dot, which is dot notation, which I almost completely forgot about,
this, we get a listing of
the
variables.
individual components of
Inside
this data
it.
type.
Yeah.
That's
Inside
right.
this data
How
type.
convenient is
Yes,
that?
very, very
It
convenient.
is very nice.
So with that, check this out. At this point, we can come and say C out. Let's say Zach's age, and we could just say C out Zach dot age. We can do anything we want with it, and no. Now let's just run this through. Think Zach's age 22.
All right.
Very, very cool. So that is kind of cool, but you know what? That's really all there is to structures. That's as simple as it is, pretty much.
Pretty much until we start talking about maybe some pointer stuff.
Yeah, if we stick as a pointer stuff, we might get a little bit scared, so don't die on us, Buzz.
I'll try not to.
Okay. So, let's go up to our character, and let's add another thing. Char name. Alright? So here's the thing. Char name is a pointer with no memory allocated for it.
And it has to be a pointer because
we don't know how long the name might be.
That's right.
And that's a bad thing if we start putting in, like, say, 80 or something. We're not really using our memory to its full advantage.
That's right. And
Optimized
we're
advantage.
all about efficiency.
And we're all about efficiency.
Except
not you,
for me.
Dan.
Joel's very much about efficiency. I take the high-level programmer stance of, let's make it easy.
Yeah.
And
Level stance of, we got a big warehouse with lots of boxes.
That's
so
right.
Let us use them.
It's not a good way, but that's okay. Yeah,
each to their own.
Each to their own, yeah. So inside of here, we want to say Zach. Well, first thing, Zach dot name equals.
And we're going to have to use that operator that we learned back in the pointer.
Super groovy.
New.
Ooh.
Because we need new memory.
Yes,
That's
we
right.
do. And instead of like an int, as we did before, it's going to be a char. And in this case, we're going to just directly allocate 80. All right, this is not directly the most efficient way in the world.
Because we just got done talking
Exactly.
about that.
Yes, but...
I win. No.
Smack. Anyway, so we just allocated 80 bytes, or 80 characters for our name. And now we need to get Zach's name from the user. So, cn, and we can say Zach.name. Just like that.
That makes sense, because we're referencing the array string that is inside the structure.
Right. And just to make it user-friendly, we can say enter Zach's new name.
I was going to say, if you said enter Zach's name, that would be funny.
Well, you know.
Programming humor there, everybody.
Yeah. Woohoo. All right. So let's run this guy.
Well, we might want to actually print out Zach's name.
You know what? I like that. So let's do that. You'll notice that we have another thing. Dan, what is our other problem, just while we're here? We allocate memory, and what do we do with it?
Well, it's like our warehouse. We're eventually going to run out of boxes, so
It's
we're going to have
raining.
to delete it.
Uh-oh, it's raining. Boxes are getting soggy. It's a bad thing. So, dink, and we'll just end out. So we just print out the name after we're done with it. Dink, print this out, enter Zach's new name. Did I do something wrong?
Yeah, we're going to have soggy boxes, but continue.
Yeah, we'll get to that.
Okay.
So let's enter Zach's new name, Joel. Alright, Zach's name is now Joel. His age is 22. Alright, I can drink now.
You've achieved your lifelong fantasy. Okay.
Alrighty. That's kind of scary. Anyway, let's come into here. And as Dan was nice enough to point out, we are missing a delete statement. So delete Zach.name.
That's right.
Isn't that hard?
Well, it's something that you need to remember.
Yes, it is something
for
that
the
you need to
beginner,
remember.
when you're dealing with pointers again and you're making new memory, you can forget this thing
Oh,
pretty
easily.
But we have to remember that we're not responsible for deleting the Zach variable.
That's right.
We're
not.
only responsible for what we made, which was the character pointer.
Yep.
The array of memory.
Exactly. So another thing that we want to point out is we have pointers, like we did in the last lesson. We talked forever about them. Well, here's where we can kind of use them a little bit.
Yes.
So let's
And
go
we're
on.
going to introduce a different form of notation for structures.
Exactly. Dealing with pointers and structures.
Pointers and structures.
Yeah. So inside of character, we're going to create a character pointer. Ooh, fancy. And we'll
So
call
now
it...
we're pointing to this unique
Structure.
setup. Yeah, this unique structure.
Yep. So we can say player. Now, player is not pointing at anything.
That's
yet.
right. It's gobbledygook.
It's gobbledygook. Exactly. So how do we create a new one?
Well, I'm going to look at the example above, which was new character,
So player
which
equals-
player equals new, and we need to say the type, which is going to be
Character. So we say player equals new character. Simple as that, right?
And we're not going to do an array.
We're not going to do
We're
an
just
array.
going to make
One.
1.
Right. And inside of here we can say player, but look at that. That doesn't work anymore.
Yeah, we don't get our little drop down happening.
What's going on? Well, the reason is because player is now just an address,
Just
like it was
holding an
before.
address, yeah.
So this address is not a structure.
Right.
So you got to be sure that you understand that. So if this is a pointer, to access the individual data items inside of the structure, you need to use what is called the arrow, which is dink and that.
Hey.
And look at that.
Pretty nice.
So now we have access to the individual component. So we can say age equals 19. And we can come in here and maybe say player, gender equals M, and everything's cool. Everything's working right. Now, I don't want it.
I'm sorry.
Go ahead.
I was saying we could print that out now. We'd
right.
just be using the arrow notation again.
Right, so we can say player, age, and end all on that one.
Yep.
And, just to add another end line before it so there's a little bit of separation. And, something.
And
so
there's
now
19.
it prints 19. So that's right.
Yep.
But, remember, since we've declared a new character, we need to give it back.
That's right. We have to delete
That's
the
right.
memory that we made.
So, delete...
Or that we took, excuse me.
Right.
That we took.
Delete player. Simple as that.
And we had to delete that because we were responsible for it.
Yeah, it was our responsibility to take it and put it back.
But we didn't have to delete the name because we never allocated any memory for it.
Right. If we, for instance, allocated some memory like we did up here for player's name, then we would have to delete that as well.
That's
so
right.
we'd have to have two deletes. But in this case, we're not allocating a new name, so everything's good. Now, there's one other thing that I think is kind of interesting, kind of important, actually, just so you can understand. Do you remember this operator? What is that?
That is the reference operator for pointers.
That's right. So if I did player, what would that be giving me?
That should give me the structured data.
Right. Well, the first element, if you will.
of the structured data.
Right. So what you can do here is if you put this in parentheses, just to say, do this first, calculate this first.
Yep.
Now if I say dot,
hey,
that works.
so we're treating this just like we were with the dot notation before.
That's right. So if you wanted to do it this way, you can as well. But in the past, you would do it this way.
That's right.
Now you have the arrow. Don't use this way unless you absolutely have to.
I kind of like the arrow versus the dot just because you know that you're dealing with pointers.
That's right.
It's very easy to differentiate between the two.
Yeah, it is. And it's a lot easier. You don't have to change this side and the right side.
And then worry about the parentheses, make sure they're correct.
Exactly, especially when you start getting variables that are really long, start getting variables from functions and all sorts of weird stuff. So you want to kind of tone it down. But you know what? I think that's all there is to structures. So,
Again,
Go with that. Yeah, that's good. I mean,
does the dumb student understand?
yeah, in this particular case, it's pretty easy to follow.
Yeah, I thought so too.
I mean, you're just dealing with it's like you're defining your own variable type. And
Yeah.
then you turn around and use it.
The big thing to remember is that a structure is a concept. It's supposed to be one unified idea
Right.
with different parts, separate parts that make up that idea.
That's it. So with that, that's going to wrap up this lesson. Thanks a lot, everyone.